Hello everyone, for first updates now, I'm Tyler Olds and you're watching Behind the Bumpers. It's a fun show where we take a deeper dive in the robots and what makes them work. And today I'm here with team number 247, the Bears out of Berkeley, Michigan. 247 has had a long history going back to 1999 with a myriad of awards, including 6 event wins, a Chairman's Award, and a couple Engineering Inspiration Awards. And today I'm here with Zach, Emily, and Kieran. And we're going to be taking a deeper dive into this modified 2020 robot, learn what they've changed for 2021, and check out some cool features all here on Behind the Bumpers.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
If you're on an FRC or FTC team and you're currently meeting safely in person and have a functional robot, we'd love to have you on our Behind the Bots or Behind the Bumpers segments. Go ahead and reach out to us on any of our social channels, on Discord, or send us an email at admin@firstupdatesnow.com, and let's get your team scheduled to be on First Updates Now. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. So, Zach, you're going to be starting out with the robot. We like to follow the power cell journey as we go through here. So, we're going to be starting with your intake. So, tell us about it and any modifications that may have been made for the 2021 season.
So, the big modification we have made is this bar across here, this piece of plexi with this L bracket bar. We buffed it up. So, because in our original design, when we could pull this intake bar up to dislodge or get a unstuck ball out of our robot, it would flex and rotate on itself and it would break. So now we fix that issue by stiffening it up so it now can no longer flex. We have moved our motor that spins the intake wheel from the right side of the robot to the left side. We now have a shorter chain. So because I kept on popping off with our last design, along with our intake bar, we have a camera right here that's attached to our hopper that has some code that's written for it to help align the driver and the robot up to balls so we can intake every ball perfectly.
Can you elaborate a little bit more on how that code actually works? So is it recognizing the ball per color or shape, and then what actually happens in the instructions for it?
The programming team that we have has used the shape and color of the ball for recognition, for distance.
So when you say recognize distance, is it actually like auto-aligning the robot as it gets driven, or like how does that work from a driver perspective then?
So it kind of orientates the robot in the general direction. So it tries to help line the yellow ball up to these green wheels on our intake bar.
So question to ask on that too. So it looks like you have some compliant wheels in the middle and some mecanums on the outside. Why have the two different types of wheels? Why not maybe just go straight mecanum for everything?
So the reason why we have mecanum wheels on the side is that so when a ball comes off to the side of the robot, these wheels will drive the ball towards the center where we have these green wheels, and those will drive them actually into our hopper. So it increases our area to pick up balls.
Sure, fair enough. So as we look at this robot, we're going to continue our journey next into the hopper, and that's going to be Emily who's going to be talking about that. So Emily, let us know what's going on with your hopper. How does it transfer from the intake all the way into your shooter, and any changes you may have made?
So our hopper holds 5 balls, and the balls travel up through the intake to the hopper. And our hopper has this really cool thing. It's the popcorn effect, where it keeps the balls like bouncing so that they don't get jammed. And we have had issues with balls bouncing out of the hopper. So to fix that, we added netting around it and plexiglass.
And then I'm going to also infer the benefit of this too is that you can load from the human player station, right, and just kind of load from the top.
Yeah.
Well, that's cool. Yeah, it definitely looks like it would be less likely to pop out. If you've clashed another robot before, do you think that there is an opportunity that could pop out, or is it held pretty secure for you?
I think it's held pretty secure. There's twist ties and stuff holding it together, so it's pretty secure.
Sure, got you there. So next up is going to be Kieran, who's going to be talking about the shooter, what you developed for that. So I'd love to hear a little bit more about that, Kieran.
Okay, so pretty much the balls transfer from the hopper from this feeder right here into the shooter. So the shooter's basically built so that way we can just kind of lean it back and forth so that way we can shoot from multiple angles if we choose to, or like depending on how far the robot is from the actual goal itself.
So can you talk to me a little bit more about the flywheel you're using? What do you know what the weight is on it? What RPM you shoot at or anything like that?
The weight is 5 pounds. We think it's about 1,700 RPM.
Sure, that's interesting. You say 5 pounds, and that's very heavy for a flywheel. But your RPM then is obviously quite low. How long does it take for that the speed up? Can we actually turn that on and watch that just so shooters speed up? I'm curious to see that. So as a follow-up on that, I mean, it looks like you're able to shoot pretty quickly, consecutively on that. How's your consistency from like your distance on that? When you shoot that quickly, are you able to kind of shoot in the same spot every time?
Pretty much, yes.
Okay, and what distances do you typically shoot from? It looks like, with your hood, with the pneumatics, typically that means you're going to shoot from a couple different positions, right? So do you have two main spots you shoot from, or can you elaborate a little bit more on that?
We can shoot from the trench, and then we can also angle the shooter back to shoot from the safe zone as well.
And do you typically, is your trench kind of the main shot you're looking for there?
Yes.
So lastly, we're going to be going into the climber mechanism. And of course, the climber is not used in the 2021 Antelope Challenges, but we're still featuring it on teams to talk about because there's a lot of cool stuff that goes on with that. So Zach's going to be taking that back over and running us through the climber.
Okay, so we have two pistons on either side of the climber to push our climber up to a total height of 6 feet and 5 inches, so we can grab the bar at any height. And then we have these wenches, which are mini sims connected to tough boxes, gearboxes. And then on those, we have a spoke with paracord, which pulls our robot up and folds upon itself. A neat feature we have is we have this wrench, which stops the motor from back driving when it's up in the air.
The Bears, once again, coming out of Michigan. I want to wish you best of luck through the 2021 season. Can't wait to see your robot back in action, hopefully at a competition soon. Thanks for taking the time to speak with us.
Thank you.
Thanks for watching. If you want more fun content, be sure to subscribe and ring the bell to be notified about our latest videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow. And check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content.